Hi guys, welcome to Esoteric Tech. My name is Gerald, and in this video I'm going to show you guys how to work with JSON in Go. Very important stuff for every Golang developer. To be specific, I'm going to be showing you guys how to generate JSON data from your code. This is the first of a two-part series, and the second part is going to focus on how to ingest JSON data. So make sure you subscribe so you can be notified when that second video is posted. Let's take a look at the agenda. I'll start off with an overview of JSON, and then I'll go through some JSON examples, which are ultimately what we're going to be creating. Lastly, I'll hop into the code and I'll show you a few different ways you can generate JSON from Go. I also want to say I'll be resuming the use of pop-up tips like this one. So nostalgic. But I received some much appreciated feedback that the pop-up tips were useful in my previous videos. If this is your first time on this channel, I use those pop-up tips as a way to provide additional insight around a topic that I'm discussing. You can think of it as tips to help you become a more complete developer. Now, let's get into JSON. First thing to know about JSON is that it stands for JavaScript Object Notation, and it's essentially a format that's used to represent or store data. So just like a struct is used in Golang or a class is used in object-oriented language, JSON is similar to that in the sense that it can hold data. But the good thing about JSON is that you can use it outside of JavaScript. Even though it's got JavaScript in the name, you don't need to know JavaScript to work with it. And in fact, a lot of the time you work with it, you won't even be touching JavaScript. I'll hop over to that last bullet point on the left in a second, but I want to go through the common use cases. One of the most common use cases for JSON is when you are working with APIs. So if you're a back-end developer, what you're essentially doing is building the back-end for some service that's going to return data to the front end. The most common format to return this data is JSON. And so regardless of whether you're a front-end or a back-end developer, JSON and understanding it is pretty much, you pretty much have to do that. It'd be tough to find a job if you don't know how to use JSON. And by the way, there'll be a future video on APIs if you want to learn more about that. It's also used in configuration files. So if you want to store data about some program, or for example, let's say you're designing a video game and the character, the user is saving the game, and you want to save information about the game itself, you know, what level they're on, what character they're playing with, their health, all that information. You might store that in some file and store it in JSON format. JSON is the primary data format used in NoSQL databases, but it's also used in SQL databases. You can actually assign that data type to a column just like you can assign a character or a numeric type. And then it's also used in schema descriptions. So when you're going through the planning phase of an API, or you're conceptualizing some object that needs to be used across your domain, a lot of times that'll be represented in JSON format. Going back to that last bullet point on the left, I'm sure there are plenty of alternatives to JSON, but a couple of the popular ones are XML or YAML. Personally, I'm not a big fan of XML, but each of those do have their individual use cases as well. That leads us into the question of why do we use JSON versus some of the other data formats? Well, for one, it's easier to read versus formats especially like XML. It's got a small footprint. It's relatively lightweight, so it doesn't consume a lot of memory, doesn't take up a lot of bandwidth when you're sending it across a network. Also integrates well with JavaScript, which is the predominant front-end language. So JavaScript is considered to be a superset of JSON. So it's syntactically similar when you talk about the objects in JavaScript and the actual JSON data structure itself. And it's kind of nice that the front-end language inherently knows how to parse and ingest that data. It also works well with other languages, which is what we'll see in this tutorial. And then there's plenty of support and tooling around it. Lots of libraries, plugins, command line tools, documentation, etc. Now, just like Golang has a set of basic data types, JSON has that as well, and that's what you see here. A couple things worth noting. We have the number data type at the top. It's important to know that JSON makes no distinction between an integer and a fraction or a float. All of those numeric types fall under the number data type. We've got null, which represents an empty value. And then we've got an array and an object. And even though those are data types, those are also considered to be JSON data structures, which means that they essentially store other fields or values. So most of the time when you're sending JSON or storing JSON, it's going to be encapsulated inside of an array or an object. Now, quick break for the first of hopefully many sessions, which I'm appropriately naming as an ET Extra. These are sessions dedicated toward helping you understand how you would actually apply this information in a real engineering role, which I know many of you are hoping to obtain. There are so many programming channels out there that are showing people how to do things in a way that really doesn't align with how you would use them in a real world scenario. And we're going to fix that. Now, if all you care about is the coding portion, go ahead and forward to that section. But what I want to explain is, why am I showing you the JSON schema first and then hopping into the Golang code second? Well, the answer is that's how you would do it in a real world scenario. Typically, if you're developing an API for some front-end service, you're going to work with your front-end counterparts to understand what the front-end expects, and they want to understand what the back-end is going to send. Once that's agreed upon, you're going to document that in the form of what's known as an API documentation or specification, and then you'll go and write your code accordingly. Even if you're writing a service that's going to make a request to some other web API, for example, the Google Maps API, you're first going to go look at their API documentation and then go and write your code. Very seldom are you going to just write your code and be happy with whatever JSON it spits out. And the reason that's important is because if you've never done that before, if you've never written your code to align with some pre-existing specification, the first time you look at it, you may find that it's more challenging than you initially thought. And that is an ET Extra. Now let's take a look at our JSON examples. As I mentioned, I found these on their web. And this outer object has 5 total fields. So we've got name, SKU, price, ship to, and bill to. This is a string, number type. And then for ship to and bill to, those fields have objects assigned to their values. And so if I'm thinking about the Golang equivalent of this entire JSON object here, I'm thinking about, creating some struct called order. And then for these fields, it's probably appropriate for me to create some other struct type. And based off of the names and values, probably a struct type called address that has these values. And then in my order struct, assign or set these to be of type address. Right? Let's take a look at orders.json. So this one, similar, except for the fact that it's within an array. So we've got an order here, an order here, similar fields to the last one, but it is within an array. So this is an array of orders. So we need to figure out how we can represent that in Golang. So let's take a look at how we can do this first one, order.json. As always, start with my package main. I already know the packages I want to import. The one of interest is going to be the encoding/JSON package. That's the one that's going to do the heavy lifting and contains the functions we're going to call to convert our code over to JSON. I also need the following packages. Now I can create my address struct type. So type address, which is of type struct. A couple things to note. Whenever you're creating a Golang struct that you intend to be marshaled over the JSON, the fields have to be exported fields, right? They must be accessible by other packages. In this case, the encoding/JSON package needs to be able to access those fields, right? And so I'm going to make sure I use a capital letter for the field names. Another thing to note here is that by default, the field name that you give it in Golang is the field name that will appear in the JSON object. But here we have a difference. You got a capital N here, lowercase n there. But I want this result. And so the way to do that is to use something called JSON tags. And the syntax for that is to use backticks followed by this JSON keyword, a colon, and then within parentheses, I'm going to put the actual field name that I want to appear in my JSON object. right? And this ensures that regardless of the Golang field name, this is the thing that you actually see in the output. And I'm going to do that for each of these fields. It's really just good practice to always add JSON tags, even if the field names are exactly what you want them to be. I also need an orders struct. All right, so now my func main, I'm going to create an instance of this order. I'll call it John, and I'm just going to give it the values that I know that I want to appear in my JSON output. Ship to. So I've got my instance there, and now the question is, what are the various ways that we can call functions from that JSON package to convert this over? Rather than kind of write one and explain one, I'm going to write them all to start off and then explain each of them. Okay, now in order to make it more clear, so you can see what I'm doing with each function, I've encapsulated the logic into my own functions, right? And tried to name them appropriately. And the first one I want to look at is this Marshal order to JSON. The most important function here is this JSON.Marshal. As I mentioned, we're calling that from the JSON package. And if I just look at the function here in the signature, we can see that this takes any, which is basically just an alias for an empty interface, right? It's just a type that they've defined in the JSON package, which is of type empty interface. And it returns a slice of byte and an error. That slice of byte is our output. That's the JSON result. And then as usual with a lot of Golang functions, it returns an error that we want to make sure we're going to check. But the key thing here is that we can pass in an empty interface, right? Any interface type, and we can expect to get back our result. But ideally, really what we want to make sure we pass in is a struct, right? And so here I've defined my instance, and so I'm just going to make a call to my own function here and pass in John, right? And I'm going to go ahead and print that out. And this is the result here. We can see that we get a JSON object. Our field names are correct, right? They're lowercase, which is what we wanted. And so that looks good there. That's just kind of a basic example of how to call JSON.Marshal. Now, one thing to note here is that all of this stuff is on one line. If I was going to save this output to a file, it would look just like this. And in fact, the only reason it looks like it's on two lines is because my screen isn't wide enough, but it really is all on one line. But what if I want my output to look like this? Well, in that case, I've created a function here called Marshal order to pretty JSON. And the difference here is that instead of calling JSON.Marshal, I'm going to call it JSON.Marshal Indent. And if I look at the signature for this function, again, we take in any, so that's going to be the the data we want to convert over to JSON. Then we've got a prefix and we've got indent. And this says, just like Marshal, but applies indent to format the output. Each JSON element in the output would begin on a new line, beginning with prefix, followed by one or more copies of indent according to the indentation nesting. So what it's saying here is that it will prefix every line with this, and then it will apply these indents based off of the nesting of the fields. And that's kind of what we want here, right? Like just here, these indents get applied based off of the nesting. So again, I'm going to call this function and pass in my instance. All right, and then run that again. All right, and we see now we've got our original input here, Marshal to JSON, and then the second one, which is Marshal order to pretty JSON. We've got that looking just like it does over here on this side. Now, I've got another example down here, which doesn't use the JSON.Marshal function. Instead, it uses this JSON.NewEncoder function, right? Now, what's that about? So here, this function, if I look at the signature here, it takes in an IO writer, right? And that's key because if you look down here, I've labeled kind of the output here, but I don't have anything that says like, you know, print the result. There's no print line statement like here. But this JSON.new encoder, when I create this instance of an encoder, I tell it exactly where I want my output to be sent. And so I'm using this os.standard output, which is just a variable in the OS package. And this standard output essentially represents my terminal, right? So I create an encoder, an instance of that, and then I call this set indent function, which this is optional. This is essentially the same as Marshal Indent, right? So we've got prefix and indent. And then last thing I'm going to do is call the encode function on this encoder, and then I'm going to give it my input. And the input and the signature for this is an empty interface, just like the JSON.Marshal functions. And it just returns an error because it's already going to send the output to this place right here, right? And so I'm going to go ahead and call that function. All right, so now the result is here, right? And this looks the exact same as the calling the Marshal Indent function. All right, so now I've shown you a few different ways you can create a JSON object from a struct in Go, but you can also create JSON from a map of string to empty interface. And that's because the layout of a map closely resembles the layout of a JSON object. And I'll show you what I mean here. Instead of passing in my struct, what I'm going to just do is create a map of string to empty interface from scratch here. Pass that into the JSON.Marshal function, and we'll see that the result looks very similar to when we pass in our struct. All right, so this particular function I'll call Marshal map to JSON, right? And then order is going to be a map of string to empty interface, right? And in this map, the field names or the keys are going to be the field names of the JSON object, and the values are going to be the values. And then for the ship to, that again is going to be a map of string to empty interface. And then the same thing for the build to. All right, and then we want this to be printed out nicely. And so I'm going to call it JSON.Marshal Indent. All right, and we see here that Marshal map to pretty JSON contains all of the same fields, but it's ordered a little different, and that's because the order in maps are not guaranteed. And in fact, it looks like it put it in alphabetical order, which is fine. Actually, the order of the fields in JSON doesn't really matter, just like the order of fields in structs don't really matter. But yeah, it just comes out a little different. But typically you would not do this. You would not create JSON from a map of string to empty interface. Typically you're just going to be using structs. Okay, so now how do I create this orders.json? How do I create an array of order? Well, that's actually pretty simple. The Golang equivalent of an array is a slice. So I'm going to comment out that code right there. And I'm going to create another instance of this order. So this one I'll call Alice. And then at the end here, what I'm going to do is stick both of these instances of order, John and Alice, into a slice of order, right? And then I'm going to make a call to my function that I created down below, Marshal order to JSON, right? And in fact, I'm going to say Marshal order to pretty JSON. All right, and now here we can see we've got those orders nicely within an array, encapsulated within an array there. Couple last things I want to show before I end this video. At the beginning of this video, I showed a few keywords. One of those keywords was omit empty, which is kind of an important one. Omit empty essentially will prevent any value from being converted or marshaled over to JSON if that value is the 0 default value for the field. So for example, if I change this to 0, right, let's say 0.0, which is the default 0 value of a float 64, and if I run this, all right, and look at the output here, we see that value right here, right? Price is 0. But if it's a field that was never actually set in my Go code, this could be misleading. It could be that that value was never actually set and it just defaulted to 0. But then in the output, it actually looks like the real value should be 0, right? And so in order to prevent that, what I can do is I can go to that field, which is here, and then I'm going to add the keyword omit empty. And what that does, as I mentioned, is prevent it. It checks to see, hey, does this field equal its default 0 value? If it does, and I'm sorry, this is supposed to be a comma there. So it comes a comma, omit empty right after the JSON tag. And then I'm going to run this again now. And now we can see that field has been omitted, right? It's not there anymore because it was the 0 default value. And then if I want to just completely omit a field regardless of the value, I can completely change the JSON tag. So let's say that I want to omit this SKU number. I'm just going to put a dash there instead. And now, again, when I run this code, now we see that the SKU number has been omitted. And I think this video has probably gotten long enough, so rather than code out the Golang to create this complex.json, I'll issue a little challenge. What I'll do is share this file, and I encourage you to go through it, then see if you can write up the Golang code for it, right? And then I'll also post a solution so that you can compare what you got to the solution that I've posted. And of course, feel free to reach out, ask me any questions that you might have. But hopefully you guys have found this video to be informative. Certainly tried to make it as helpful as I possibly could. As always, I appreciate you guys taking the time to watch this video. Please do subscribe, like, let me know if you have any questions. Feel free to comment, and I will see you on the follow-up video to this, which is how to ingest JSON in your Golang code.